All right, hello everyone. So today we're going to talk about factoring out the GCF. So the GCF is going to be our greatest common factor. So the other day we were talking about how to factor, and this is going to be factoring out the greatest one of those. So if you missed those notes, please go back and look at them on Teams. That's going to help you out if you're not sure what a factor is or what common factors are. Okay, so we're going to talk about it a little bit, but we're not really going to review in this video. Okay, so like I was saying, that's the greatest common factor. That is the biggest factor that you could divide out of each number that is in your set. So to find the GCF, I have a few tips. You could create a factor tree. Remember, a factor tree is going to be something like, let's say our number is 12. Our factor tree would have 1 and 12, 2 and 6, and then 3 and 4, because those are all factors of 12, all together in a little tree with little branches. Okay, so you could do that for each of your numbers and then try and see what the largest of those is that they have in common. Or you can start with the smallest number that's in the set and then see if that is something that could divide into every other number. So like if we look at our examples here, we're trying to find the greatest common factor for these. I'm looking at 8 because that's the smallest number in this set of 3. I want to see if that will go into each of these. So I'm going to divide each number by 8 and see if that'll give me a whole number. So I know 8 divided by 8, that's going to be 1. I know 16 divided by 8 is going to be 2. And 32 divided by 8 is going to be 4. So all of these are whole numbers, which means that 8 is the greatest common factor here. That is a factor that they all have in common. If we were to multiply 8 by 2, 4, and 1, we would get each of those numbers. Okay, so let's take a look at the next one. Like that tip says, I'm going to start with the smallest. That's going to be 12. And see if everything else is divisible by that number. If it is, that means that everything we should get will be a whole number, which we do have. Cool. So the GCF for the second example is going to be 12. All right. So let's take a look at some slightly different looking ones. Now, these just look different. The idea is still the same, where we're trying to divide out the biggest number that we can. So I'm looking at this. We got 6, 3, and 9. So once again, I'm going to start with the smallest number, see if that goes into all of these terms. Let's see, 6 divided by 3 is going to be 2. 3 divided by 3 is going to be 1. 9 divided by 3 is going to be 3. Cool. All of those are whole numbers. Therefore, our GCF for this is going to be 3. That's the biggest number that can come out of all of these. All right, let's take a look at the next one. So, smallest number here is going to be 10, but I already know by looking at these that 10 is not going to go in there. If I were to try to divide 15 by 10, I would end up getting 1.5, and that's not what we want. We can't have any decimals. So I'm going to need to go a little bit smaller than that. Looking at these, the next number that they would have in common would probably be 5. So let's divide each of these by 5, see if I'm right. 15 divided by 5 is going to be 3. 25 divided by 5 is going to be 5. 10 divided by 5 is going to be 2. Cool. So that works. I'm also noticing something else, though, that these have, or rather don't have, that these do. So I'm looking at the x's here. Each term has an x in it. So when we have a coefficient and a variable, that means that those two things are being multiplied together. So what I can do is divide out an x from each of these because they all have an x in common. So my greatest common factor would actually be 5x, like that. So if I were to divide out an x from each of these, we would need to take a look at our exponents and our x's. So remember, if it's to the third power, that means you have 3 x's. So you have 3 at the top, 1 at the bottom. You're going to subtract these two. So 3 take away 1 is going to be x squared. Let's see. For the next one, I have 2 x's on top and 1 at the bottom. 2 minus 1 is going to be 1. And then this one has 1 at the top, 1 at the bottom. So that means we have no x's left on that one. So the only reason why we could do that, again, is because they all have an x. That is the only reason why we can divide that out of each of those. Okay. So the reason why we're doing this, finding our greatest common factor, is because we want to take it out. So I'm going to go to the next page of our notes, which is down here, where we are factoring or undistributing our polynomials. So this is going to be kind of like dividing, but not exactly. We're using division, but it's not exactly the same thing when it comes to polynomials. Because we've already added them, we've subtracted them, we've multiplied them. Now we got to have our form of division, okay? So we are going to call this factoring or undistributing. Because what you're going to do is split these split this one piece into 2. So then we could see like where we started out with our expression. So let's take a look at these steps. There are only 3 of them. The first one is going to be find the GCF. Okay, here's our example. So I'm looking at these numbers and I'm trying to figure out what the biggest one is that will divide out of all of these. Now I think 9 is going to work out here. But I'm also looking at this, and again, all of them have an x in it. So I know that I could also divide out an x. Okay, my GCF is going to be 9x. All right, step number 2, divide each term by the GCF. So starting with my first term, I have 9x cubed. 9x cubed divided by 9x. You're going to look at your bigger numbers and divide those two. So I have 9 divided by 9, that's going to be 1. And then I'm going to look at my x's here. So I have 3 on top, 1 at the bottom. So 3 minus 1 is going to be 2. I have 2 x's left over. And then I'm going to go on to my next term. I have 18x squared divided by 9x. Once again, you're going to look at your big numbers, divide those. I have 18 divided by 9. I know it's going to be 2. And then look at your x's. I have 2 on top, 1 at the bottom, so I'm going to take 1 away. I have 1x left over. And then we have our last term, which is 27x. And we're going to divide that by 9x. Okay, big numbers get divided. I have 27 divided by 9. That's going to be 3. And then I have 1x on top and 1 on the bottom. So 1 take away 1 is 0. So I have no x's left. All right, then we're just going to bring down the signs that they had between them. So those are just pluses. Okay, we have divided each term by our GCF. So now we can move on to step 3, which is rewrite the expression with the GCF in front. Okay, our GCF was 9x. And the remaining, it should say remaining, factor in parentheses. So here's my parentheses. I want to write this entire thing right in here. So I got 1x squared plus 2x plus 3. And that is going to be my answer for this question. I have factored out our GCF, literally taking it out of your expression and then writing what's left over after you do that. Okay, so those 3 steps are what we're going to follow every single time. So let's scoot down a little bit to number 1. We're going to follow those same steps. Step 1 was find your GCF. Let's see. Looking at these numbers, I have 12 and 3. I think 3 will be my GCF because I know it's for sure going to come out of 12. 3. And then let's see, they both have an x on them, so 3x will be my GCF. Okay, GCF found. Step number 2 is going to be dividing each term by the GCF. So I have 12x squared divided by 3x and 3x divided by 3x. Okay, divide your big numbers. 12 divided by 3 is going to be 4. And then take care of your x's. I have 2 on top, 1 at the bottom. 2 take away 1 is going to be 1. Keep that plus sign. And then our next term. We have 3 divided by 3. That's going to be a 1. And then we have 1x on top, 1 on the bottom. So that's going to leave 0 x's behind. Okay, that was step number 2. Step number 3 was rewriting this with your GCF out front and the rest or the remaining part of your expression in parentheses. So I got 4x plus 1 because that's what's left over after we take out that 3x. So we're undistributing here because if we were to go forward, we would multiply that 3x by everything on the inside and end up getting this as our answer. Right now we're working backwards from what we were doing when we were multiplying. So opposite of multiplying is dividing, but for us we're calling it factoring because we're not exactly doing that. Okay, so let's try number 2. Okay, number 2. Let's start with step number 1. That's finding our GCF. Let's see, looking at these numbers. 10 is the smallest one we have, but I don't think that's going to work with 15. So next number that would come out of all of these would be 5. Okay, let's see. Do they all have an x? No, there is no x here. So we cannot take out an x. Our GCF is just going to be 5. All right, next step was to divide each term by our GCF. That's just going to be 5. Okay, so 15 divided by 5 is just going to be 3. There is no x to take away here, so this x is just going to come straight down. Sorry, this x squared is just going to come straight down. Okay, keep that plus sign. Then we divide these two. We got 10 divided by 5. That's going to be 2. The x is going to stay on. And then we got the last bit, 20 divided by 5. That's going to be 4. Cool. That's step number 2. Step number 3 is rewrite our GCF out front and the rest in parentheses. If we were to go forward and distribute these in, we would end up with this as our answer. So that's a really good way to double check your work if you wish to do that. Okay, so those 2 we got done. The rest of these we did in class. So if you want to get the answers to these, totally let me know and I will help you out. But I'm going to leave these for you to practice. If you have questions, let me know. If you need extra practice, that's on Teams. I think that's going to be it. All right, have a good day, y'all. Bye.